My name is Joe Hinkle. This training video is on long-range technology available from HolidayCoro.com. What you see in front of you is what's available. At the very top is the HinksPix Evolution. It's a CPU for the Flex system. The middle is a HinksPix Pro for the Flex system. This is a long-range driver transmitter board, and this is a long-range receiver. Now, both the Flex Evolution and the HinksPix Pro can drive 1, 2, or 3 of the long-range transmitter boards. On the long-range transmitter boards, you find 4 Cat5 connectors. A cable comes out of one of the Cat5 connectors, and it connects to the input port of the long-range receiver. That Cat5 cable can be anywhere over 200 feet, possibly up to 600 or 700 feet, depending on the type of cable you're using and other such things. The HinksPix Evolution will drive 2 universes or 340 pixels out of each one of these port connectors. Now, for this video, I'm using the term port to specify a green Euro connector that you physically attach a string of pixels to. So a long-range receiver, this one in particular, has 4 ports on it. And it connects to one of these 4 output Cat5 ports. So, as I said, the HinksPix Evolution is 2 universes or 340 pixels. The HinksPix Pro is 4 universes or 680 pixels. Now, the rest of this discussion is going to be about smart long-range technology, and that only applies to the HinksPix Pro. So let's go ahead and move the Evolution board. We're going to head and remove the smart. We're going to talk about the HinksPix Pro driving a long range. Now, as you saw, a single long range receiver has the capability of driving the 4 ports that are associated with the 4 data streams coming out of a Cat5. So what is smart technology about? Smart technology allows you to put more than one board coming off of a Cat5 data stream. HolidayCoro's implementation of smart long-range technology allows you to put 16 boards coming off of one Cat5 cable. And the distance between any one smart long-range receiver is anywhere from 200 plus. I've tested 4 of them at 200 feet apiece, well over 800 feet between the HinksPix Pro and the last long-range smart receiver. So, real quick, this is a long-range smart receiver. I'll bring this out and talk about it a little bit more, but graphically, this is what a long-range receiver does. Excuse my drawing. You have a Cat5 cable that comes out. It will go to a smart receiver. Now, the long-range smart receivers from HolidayCoro has 2 outputs. So we can actually come out of here, and we can come out of here. And we can go to another long-range receiver. And we can go to another one here. We might just want to daisy chain this one and go here. This one, we might want to do this. And then come out of here and come all the way back. So you can see how the ability of coming off a smart long-range receiver with two outputs. Now remember, every one of these lines is a long-distance transmission protocol RS422 line that I've tested at 200 feet. Depending on the type of cable you're using and other such things, may be able to go all the way up to 300, 400, 500 feet between nodes. So this is what we call smart technology. You can have up to 16 boards on any one port. These 16 boards are uniquely identified. So let's now talk specifically in general about where our smart long-range technology is going, and then I'll dive in very specifically to the smart board. The Smart SPI 4 board. As I mentioned earlier, this is the Holiday Coral Smart Long-Range Receiver Board. It provides 4 SPI outputs. Each output is capable of delivering up to 680 pixels. That's not the only long-range technology we have. We also have, I got to put this on the side, we also have AC technology. What you can do with this board is take one of the 4 streams of data, identify 6 pixels that will be extracted from that data stream. Those 6 pixels become 16 AC channels. You've got a full-fledged 16-port AC controller based off of pixel transmission. What we have in prototype right now take this board and effectively make one board that's got 16 outputs. We've got a 16 output smart long-range differential. Think about it. Coming off of one Cat 5, you could drive 2, 3, 4, 5 megatrees, all coming off of a single Cat 5 with Holiday Coral's 16-port smart receiver board. What's in development, and we should be offering it before the end of the year, hopefully for the Christmas, it will be a 64 by 64 P10 or P20 matrix board driver coming off of smart long-range receiver. So coming off of one Cat 5, off of our long-range transmitter, you'll be able to directly drive a 64 by 64 color pixel matrix. So now let's talk specifically about the features that are on this 4-port SPI board. As I said before, each Cat 5 cable contains 4 data streams that typically drive one of 4 ports. Here's the 4 ports. So this would be port 1 through port 4. There are 16 possible boards. The board identification is via this dip switch. With the 4 switches, you can identify board IDs from 0 through 15. Now, you cannot have the same ID on the 2 boards on the same data stream. So the 16 that are on a data stream have to be uniquely identified. There's a test button. When you press the test button and enter test mode, you'll get different color of lights flashing directly from the pixels attached to your SPI board. It's very good for testing to make sure your pixel strings are actually working and separate that from the software lighting control that's coming from your controller. All these smart boards are also field upgradable, which means the firmware that's on the microprocessor that's on this board can be updated directly from the HinksPix PRO Controller through the long-range differential driver. There is one Cat5 input and two Cat5 outputs. Each of these are totally separate. Each of them are capable of driving over 200, possibly up to 600 feet. On the 4 fuses, there is a red light associated with each of the fuses. The red light is on as long as the fuse is good. If a fuse blows, the light goes off. There is a green LED associated with each of the output ports. The green LED allows you to immediately see what ports have been actively programmed in the HinksPix configuration page for long-range differential drivers. What that means is you have a board ID. I'll have another video on how to configure this within the HinksPix Pro web configuration page. But you have an ID that identifies how these pixels or how these ports are going to be driven. Now, not all of the ports need to be active. You could activate 1 or you could activate any number up until 3. When you activate a port, a green light turns on that port to validate for you that that board will actively pump data out that specific port. Now, in the configuration page, you might say, well, how do you figure this out? Excuse me, not how do you figure it out. How do you know what pixels are going where? Very briefly, consider the Cat5 having a data stream, we'll just say 680 pixels. Well, the very first pixel that comes out is pixel 1, and it goes all the way down until you have pixel 680. What you do is if a port is activated, you tell it what the first pixel should be coming from this port. So, if I want, this could be port 1 off of data stream 1. This might be pixel 101 coming off of data stream 2. So you're allowed to pick what pixel, what's the first pixel that's activated coming off any one of these ports. Now, lastly, I just want to share a implementation trick. Let's say you're using long-range receivers. Let's say that in your display, you want leaping arches. Now, typically, if you want leaping arches, you can program them separately. Let's say for your implementation and for this discussion, you want 2 arches to behave always exactly the same. Instead of programming channels within X lights or whatever you're programming, instead of having data stream for arch 1 and arch 2, you might have this being driven by smart receiver number 1, this one driven by smart receiver number 5. They're both connected to port 1. This is coming out, this is channel, we'll just say channel 10. If this is connected to port 1, and it's also channel 10, and these are all connected together, then the data that's going to this arch is exactly the same data that's going to this arch. So if you want various objects within your display to behave exactly the same way all the time, you simply just have to program the smart controller to say, hey, they're both going to start on the same channel. This concludes the hardware discussion on the long-range smart receivers available at Holiday Coral that have to be driven by the HinksPix Pro. Have a nice day.